Welcome to Notes Trig 1.4 and Pre-Calc 4.4. What these notes are going to cover is talking about the concept of a reference angle. So first let's actually just look at a triangle here that's in the first quadrant. If it's on our unit circle, one of the definitions we know from a unit circle is that the radius is going to be 1. So this distance is going to be 1. So let's say that we have some xy coordinate point here. What I know about that coordinate point without assigning it specific numbers is that the x value will be positive, the y value will also be positive because it's in the first quadrant. So if I asked you to find the sine of this angle theta inside of our triangle here, you would use the idea that this is a right triangle, and you would use SOHCAHTOA, opposite over hypotenuse. Opposite side being y, hypotenuse being 1. So what we can really say here is that the sine of theta is equal to just y. Okay, let's apply that same concept now for the cosine. Going back to SOHCAHTOA, cosine is adjacent over hypotenuse. Adjacent side would be x, radius would be 1, or hypotenuse would be 1, so we can say that the cosine of theta is equal to just a positive x. And for the tangent, that's opposite side over adjacent. Opposite side is y, adjacent side is x. So the tangent of theta is equal to y over x. These are going to be three formulas that are going to be key for us to know. Those formulas are on the formula sheet that I gave you. They're listed here again as well. What happens though, again, what happens if we were in the first quadrant here? What happens if we move to the second quadrant for this example? Let's pay attention to what happens to our values of our sines and our cosines and our tangents, whether they stay positive or do they change to negative. So if I move to the second quadrant, what happens is my x value is going to be negative, but my y value will still be positive because I'm going up the y-axis. So following the definition of opposite over adjacent here, or excuse me, opposite over hypotenuse, we would take y over 1, and we would get sine to be positive still, a positive y. The cosine would be adjacent over hypotenuse. Adjacent side would be negative x, and hypotenuse would be 1. So notice now that the cosine is equal to a negative x. Okay, before it was equal to positive x. When I move it to the second quadrant, it's equal to a negative. Sine in the first quadrant is equal to y, but in the second quadrant, it's also equal to y. So those are the same, whereas cosine changes from positives to negatives. And we're going to notice as we move from each of these quadrants that the sign of the sine, cosine, and tangent, sine meaning plus or minus, will change based upon the quadrants that we're in. And that's the next concept we're going to talk about here in just a minute. So if I finish this out, we would say for the tangent would be opposite y adjacent negative x. So we find that that also changes as well. That becomes negative when I move to this quadrant. And it's going to be very important that we recognize where sine, cosine, and tangent are positive versus negative. That's what I want to take a look at next. So now that we know that the sine is actually equal to the y value, the cosine is equal to the x value, and the tangent is equal to the y over the x, those are the three formulas we just discussed, let's take a look at where the sine values are positive and negative in each of our four quadrants. Well, y values as I go up are positive, so I know that sine would have to be positive in both of these quadrants. And then, it means that in these two, when I go down, they would have to be negative. Also, just so you're aware of when we number these quadrants, this would be quadrant 1, this would be quadrant 2, quadrant 3, and quadrant 4. So wherever the sine is positive and where the sine is negative, the cosecant will also be the same. So we can say that this is where the sine and the cosecant are positive and negative. Likewise for the cosine. Wherever the cosine is positive and negative, so will the secant. So let's talk about where it's positive and negative. So the x values now going this way are positive, so they'd be positive in quadrant 1 and quadrant 4, whereas they'd be negative in quadrants 2 and 3, because the x values are negative this way. Tangent's a little bit more complicated. When we think about the tangent, we've got a positive y in the first quadrant and a positive x, so a plus over a plus is equal to a plus. So really what I just did here is I did a positive y divided by a positive x. and that's going to give me a positive answer. That's why I'm getting that in the first quadrant. Well, likewise, in the third quadrant, I'm going to do negative y over negative x, and I'm going to get a negative answer here. And then if I move to the second quadrant, I'll do a positive y over a negative x, so I'll get a negative answer here. And then finally, in the fourth quadrant, I'll do a negative y over a positive x. And they'll end up with a negative. And I'm just realizing that I made a mistake here. I'm not going to have all three of these be negative. If I go back to my third quadrant here, the reason I did that one next is because I knew that was going to be positive. Negative over negative is going to give me a positive, and I wrote that down as negative, so that was a mistake. So this is where my tangent is positive in quadrants 1 and 3, and in 2 and 4 it's negative. And that's also where cotangent is positive and negative. This is going to be a really important chart for you to know. So I would star this, circle it, highlight it, do whatever you need to do to make sure that you know where the sine, cosine, and tangent, which quadrants they're positive and negative in. This is a good thing to put on the back of your formula sheet because it's something that I'll let you use on your test. Right on the back of the formula sheet. Okay, this next section is actually getting us to actually deal with now the concept that's the main concept of this section, which is a reference angle. So let's first define it. It says the reference angle is a positive acute angle, and those are both important for you to know. Positive and acute angles that can represent any angle of any measure, and we'll talk about that in just a minute here. So as we're drawing these positive acute angles, the key here is that we always want to make sure they go off of the x-axis. So drawing them in the second quadrant, so over here in this quadrant, always draw a line. Part of your triangle is going to come off of the x-axis. Then you're going to have your hypotenuse of that triangle coming off through the origin, and then you form your right angle from there. So this would actually be the reference angle in the second quadrant. Again, it's an acute angle. It's positive. It's a positive measurement here, and it's less than 90 degrees. Where students make the biggest mistake is they'll try to draw it off of the y-axis. You need to make sure that you're always drawing these off of the x-axis. So let's apply that same concept in the third quadrant. So always start by going off of the x-axis in that quadrant. So third quadrant is down here, so that's the x-axis. Then go from the origin to make your angle, and then there's your right angle. So that's my reference angle here in the third quadrant. So the triangle would look like that. If you're talking about drawing that reference angle in the fourth quadrant, so in the fourth quadrant we're down here, first draw the x-axis, then draw your angle coming off of the origin, and then make the right angle here. So this would be the reference angle in the fourth quadrant. And what's going to be important is that we actually know where these angles are, and that we can draw the triangles that would look like these three do, depending on whether we're in each of those quadrants, second, third, or fourth. A good idea to remember, and this is a diagram here, when you draw your triangle it should be part of this bow tie. So this would be what the 4 different triangles look like in those quadrants. Again, I drew the 3 of them. I didn't draw the first one because we've dealt with the first one already. Let's talk about actually finding reference angles now. If I asked you to find the reference angle for 160 degrees, remember that the definition says that it must be a positive acute angle. So what you really want to do is figure out which quadrant is 160 degrees in. So if you think about this, there's 0 degrees, 90, 180, and 360. So 160 degrees has to be in the second quadrant. So if I draw a 160 degree angle, it would be something like this. That would be this angle right here. That's 160 degrees. Now the reference angle in the second quadrant, because that's what quadrant that this 160 degrees is in, would actually be this angle that I'm going to draw in blue, starting from the x-axis, going over to my angle. Draw that a little bit nicer. Would be right here. That's the reference angle. The reference angle here, you would think about it like this. If I've gone from starting at the x-axis and going all the way over here 160 degrees, and if I went all the way to this x-axis in the second quadrant, I've gone 180 degrees. I just need to think about how much further did I go. So I'm basically doing 180 minus 160, and I would say then that the reference angle would be 20 degrees. So this angle in blue is the 20 degree angle. When you're making your notes, it's going to be very helpful to draw these in different colors. If you're trying to draw them all in pencil, then your reference angles will not pop out and they'll be very confusing. So I'd either get a highlighter or something of a different color to draw this in here. Let's apply, so my answer is actually 20 degrees. Let's apply that same concept to 230 degrees. So 230 degrees, 0 degrees, 90 degrees, 180, 270. So I start here, come all the way around, that's 180, I gotta go past 180 but not quite to 270, so it would be in the third quadrant. So I'm in the third quadrant. If I draw my reference angle, this time I'll draw it in red. My reference angle, starting on the x-axis here, going over to my angle that I drew, this would be my reference angle. That's what I'm trying to find, this theta. So here's what I know. The blue angle that I drew, that is 230 degrees. So I want to know how much further past 180 did I go to get to 230. Well, 180 plus 50 is 230. So basically what I'm doing is I'm doing 230 minus 180, if you want to think about it that way. I think the easier way is to think about it like I explained. How much further past 180 did I go to get to 230? That was 50 degrees. So the red angle, actually right here, I should draw that in red. The answer, that red angle, is 50 degrees. That's my reference angle. Okay, taking a look at the next one. This time my angle here is in radians instead of degrees. So let's go through and measure this, or label this in radians. That'd be 0 pi. This would be pi over 2, but notice that I'm given a decimal. So if I just convert that, that's the same as half pi, which is 0.5 pi. So up here would be 0.5 pi. This is the same as pi, or if I write that as a decimal, it'd be, well, it wouldn't really be a decimal. If I just put my number in there, it'd be 1 pi. And then this would be 3 pi over 2. As a decimal, that'd be 1.5 pi. And then finally, this would also be 2 pi. So if I'm going to put 0.7 pi on here, I'm going to start off here. I'm going to go up to 0.5, but I don't want to go all the way to 1. I want to go to 0.7, so this would be that angle. This would be 0.7 pi. So now I'm in the second quadrant. To draw that reference angle, go from the x-axis in the second quadrant over to my angle. This would be the reference angle that I'm trying to find. So if I think about that, I want to think about if I went all the way over here, I'd go to 1 pi. I didn't go quite to 1 pi, so if I do 1 pi minus 0.7 pi, I'd be left with 0.3 pi. And so that would be my reference angle, 0.3 pi. Applying that same concept with 1.8 pi, again, I've already labeled these for you in this previous one, so if you label them again, I know that this is 2 pi, this is 1.5 pi. I could keep going 1 pi, 0.5 pi. My angle for 1.8, I'd have to come all the way around there. That's 1.5. I want to go past 1.5, but not quite to 2. So the reference angle now, we're talking about the fourth quadrant. Starting here, that's the x-axis in the fourth quadrant, going down to here. So to find that measure, I want to say, okay, how much further past 1.5 did I go to get to 1.8, or how much further would I have to go to get to 1. Let me say that again. I don't want to know that distance. I want to know this distance. So I would do 2 pi minus 1.8 pi, 0.5. I don't want to know this distance, so I made a mistake there. So this angle right here would be my reference angle, which would be 0.2 pi as my answer. Now if I'm dealing with a negative angle, if I want to draw negative 140 degrees, I'll start here and I'll go this way for negative. That'd be negative 90. To go all the way to here, that'd be negative 180. So I know I'm going to be in the third quadrant here. So I'm in the third quadrant for negative 140 degrees. Now the reference angle would be going from the x-axis in the third quadrant, which would be here, over to there. So if this angle is negative 140 degrees, really the measure is 140, the direction is negative. How much further would I have to go to get to 180? Well, this distance right here should be 180 minus 140, not minus negative 140. And I'd find that my reference angle would be 40 degrees. So remember that it has to be a positive acute angle, not negative. but positive.